Welcome to The Explainer. Today, we're diving into what is arguably the internet's most important dynamic duo, the client and the server. We're going to unpack that invisible, constant tug-of-war happening behind the scenes between blazing fast performance and ironclad security.
Right. So think about an everyday scenario for a second. You go to a website, you type in your username and password, and you hit enter. But here is the million-dollar architectural question. When you initiate that login, where exactly should that password actually be verified? I mean, should your web browser just check it locally right there on your phone or laptop? Or should a remote machine halfway across the world handle it? The answer to that question unlocks exactly how modern web applications process our most sensitive data.
You see, a web application isn't just one massive piece of software running in one place. It's actually a shared workload. On one side, we have the client, and on the other, we have the server. And these two are constantly chatting back and forth via HTTP requests and responses. They basically divide up the labor to make sure your experience on the web is incredibly smooth, but also highly secure. So let's break down exactly who does what in this relationship. First step, the client. In technical terms, the client is your local execution environment. Basically, your phone, your tablet, or the web browser on your computer. Its absolute main job is rendering the interface you actually see, using HTML and CSS. But crucially, it also runs client-side code, usually JavaScript. The client is all about immediate interaction. By tweaking the web page's DOM, the document object model, it can update the interface locally and instantly, completely bypassing the need to wait for a network connection. Then, on the flip side, we've got the server. Think of this as the heavy lifter. It's a remote, highly trusted computer that hosts the core logic of the website, constantly listens for incoming messages, and, this is the big one, it securely manages databases and private files. If the client is the flashy, interactive storefront that you walk into, well, the server is the heavily guarded vault in the back room where all the real valuables are locked away. So how do the storefront and the vault actually talk to each other? That bridge is called an HTTP request. This is data actively sent from your local browser over to the remote server, and it is happening constantly in the background. Hitting enter on a URL, that generates a request to load a page. Submitting a registration form, that reaches across the web, sending a very specific payload of data to ask the server to do something for you. And of course, the server has to answer back, right? It does this with a response. Once the server finishes processing whatever payload you sent it, it bundles up the necessary data and shoots it right back to your browser to complete the loop. This could be the HTML needed to load the next page, a chunk of JSON data to update a live feed, or even just an error message if something broke. This endless loop of requesting and responding is literally the heartbeat of the entire web. Now, because of this setup, we have two very different ways to process information. Let's look at client-side processing first. I like to think of this as the sprinter. Because this code executes locally right in your browser, it is insanely fast and super interactive. It also saves the backend a ton of work because you aren't sending data across the internet for every tiny little click. It's absolutely perfect for things like hiding a drop-down menu, making sure a form field isn't empty, or showing a live character count. But there is a fatal flaw here. The client is fundamentally untrusted. Since the code literally lives on the user's device, anyone can view it, change it, or just completely bypass it. You absolutely cannot trust the client with secrets. And that brings us to server-side processing. This is our trusted environment, the vault. The server is where you handle the serious, heavy-duty stuff. It's incredibly secure because the codebase is isolated. Users can't see it, and they definitely can't tamper with it. It's entirely controlled by the site owner and has direct access to databases. So this is the only place you'd ever put sensitive tasks, like logging someone in or processing a credit card. The catch? Well, it's latency. Every single server-side action means data has to travel across a network, which slows things down and increases server workload. So we end up with this massive, fundamental trade-off in web architecture: client-side speed versus server-side security. You obviously want your app to feel instantaneous, which means pushing as much work as possible to the client. But you also need your app to be unhackable, which means keeping the important work locked safely in the server. You really can't just pick one. Building a great web app requires a really masterful blend of both. Let's actually put this into perspective with some everyday web tasks. Industry standards cleanly divide these jobs based on how much trust is required. Showing an animation or hiding a menu, that definitely belongs on the client side. It needs to be fast and local. What about making sure you didn't leave an email field blank? Client side again. Just a quick check before we bother sending anything over the network. But what if you need to check a password, process a payment, or actually save changes to a user profile? Boom, those immediately get delegated to the server. They require database access and a level of security that your browser just cannot guarantee. Okay, let's go back to that login dilemma from earlier and map it all out. Here is the perfect tag team for a modern login system. You type in your username and password. Instantly, the client-side code jumps in and does a preliminary check just to make sure you didn't leave the fields blank. It's totally instant. Only after that local check passes does the data actually travel across the web. Then, the server steps up, acts as the secure vault, and queries the database to see if your credentials actually match. Finally, the server shoots back a response, either logging you in or throwing an error. The client made it snappy, but the server made it secure. You see this exact same brilliant choreography when you're shopping online too. You click Add to Cart, and the client instantly updates that little basket icon in the corner using JavaScript. It feels completely immediate. It might even show you some local delivery options right away. But when you actually click Buy, the server takes the wheel. It securely checks the real-time database to make sure the item is actually in stock. It calculates the final price, where you can't tamper with it, and processes your credit card. Finally, the server saves the order to the database. It is a flawless handoff from a fast user interface straight to a highly secure transaction. Which leads us to what is basically the golden, non-negotiable rule of web development. Never, ever rely solely on client-side validation for sensitive data. Because the user has total control over their own browser, that trust boundary is too easy to break. The server has to be the final authority on security. You absolutely should use the client to make things feel fast and fluid, for sure, but at the end of the day, the server is the ultimate bouncer at the door. So, wrapping up this explainer, I want to leave you with something to think about. Our phones and laptops are getting insanely powerful, packing incredible processing capabilities right onto the device. So as these local environments get more and more sophisticated, what secure tasks will the server eventually trust the client to handle next? I mean, with new cryptography and local storage tech evolving every day, the balance of this dynamic duo is constantly shifting. Just keep that in mind the next time you instantly load a complex app or securely buy something online. Thanks for joining me, and keep questioning how the digital world around you actually works.